Okay, hi everybody, and welcome to the last day of April. We're so glad that you joined us on our Multi-Cloud Happenings Ask Tom webcast. We're really excited today to talk to you about the maximum availability architecture. And if any of you have been around Oracle for a while or just any short period of time, hopefully you've heard about that blueprint that we have called maximum availability architecture to keep your applications up and running. So today, my name is Tammy Bednar, and I am a product manager that focuses on our database services in the cloud and multi-cloud as well. And with us today is Suzanne Holliday. Hey, Suzanne.
Hey, Tommy. Hey, Sina.
Good, you're here today. And Sinan is going to be our expert or our expert person to talk to us about MAA itself. So, hey, Sinan.
Hello, Tammy. Hello, Susan. Thank you for
Oh,
having me today here.
absolutely. Okay, so let's get started because I know this is a topic of great interest, especially wanting to keep your applications up and running. So first of all, let's just level set where we're at. We are going to talk about the maximum availability architecture in the context, of course, of multi-cloud, but more specifically about the solution Oracle Database at Azure. So as some of you may have noticed, back at the end of 2023, we added a new solution for multi-cloud to make it much simpler, to allow you to choose the best application and data plane that you want to use, but also be able to lower the latency of running those applications and that database plane within different cloud providers. And that's where we added or expanded, I should say, our partnership with Microsoft, which we call Oracle Database at Azure. So what that does is it actually places our hardware or our platforms, I should say, that we run our database services on more closely aligned within the Azure data centers. Now, with our services being co-located in the Azure data services, this means that you get to choose, you're in control, are being able to run the workloads where you choose. You know, we have there's lots of flexibility in the cloud about where you want to run your databases, where you want to run your applications as well. And so this is giving you the opportunity to say, hey, this is the solution that I want to run my applications in Azure, but I want to run my Oracle database on the Exadata platform. And so you get to choose that and be able to run those applications or that solution with very low latency and very fast provisioning as well, making it really easy to provision those services within the Azure portal. And we've done some extra work to help use that native Azure portal if you're used to that kind of interface and those UIs to be able to very easily provision the Exadata database service that's co-located in the Azure data center as well. Now, being able to provision and run the native cloud tools means that it's going to make it really easier to migrate and modernize and innovate your applications that you want to run within those regions and data centers as well. So we make it really easy and give you by using the Exadata database service and being able to use your Azure applications. This should give you a lot faster on-ramp to working within the cloud, which gives you more time to focus on the applications and the business. Now, also a third benefit of this is being able to simplify operations and purchasing. So we have added a process that makes it very easy for you to go into the Azure Marketplace, being able to provision those Oracle database services, and then very quickly spin up your applications and start working on the development or the running of those applications for production as well. So we're really excited, and we continue to talk about this solution because we hear a lot of excitement from you as customers as well. So this is really great to work with everybody on this multi-cloud solution. As you can see that as of April of this month, 2024, we now have 3 live regions available with the Oracle Database at Azure solution. In the US, we have US East that is available. In the UK is UK South. And then in Europe, we have Germany West Central, which is the final one that just came on, or the last one that just came on board live. And as you can see, we have 13 additional regions planned for 2024. And we're really excited about adding these additional regions. And the reason that this is so popular and why we're adding these regions is because we're listening to customers like you that say, hey, this is where we need our workloads to run. Can you help us out? And so this has been a great partnership with Microsoft to work with them, to work with customers like you to come up with these solutions together. Okay, so Suzanne, why don't you tell us about our Exadata database service that's running at Azure today?
Yeah, sure. Thank you very much, Tammy, for the some nice introduction. So everybody pretty much is familiar with Exadata. It's been out a very, very long time. It's an industry-leading platform, and it's been established because it really is the best performing, highest available, and the most secure platform. So this is why we herald it as our really go-to database for mission-critical workloads, as well as other workloads, which I'll explain in a little while, because with the special technology that we've built with the hardware and the software engineered together, for example, the scale-out database servers, as well as those scale-out intelligent storage servers, that delivers a lot of hardware and software smart capabilities for the database. And this really distinguishes us against, say, other converged platforms. And with all this performance and this scalability and availability, we can offer that at the lowest cost as well, given what we can, perform and price performance and so forth, with pay-per-use database cores and online elastic resource scaling. And this deep engineering, it really integrates that hardware and software, like I said. And this is why we're able to now deliver it, like you say, Tammy, optimized as a database platform into the Azure data centers for Azure applications to use, which is really exciting time for us. It's a co-managed model. So what that means is that we, as Oracle, we own and manage the infrastructure. So when we put it into the data center, we do own that. And we have a duty to you as the customer, whereby we will actually perform and take a lot of load off you in terms of the administration and patching and so forth of, database, the storage servers, internal networking, hypervisor, especially the patching and the security updates. So the customer, you would manage everything else above the hypervisor. So what that means is that we have a lot of fantastic cloud automation that's built in, and this is provided to you so you can create, delete, patch, backup, scale up, scale down, and so forth. Also, either in the UI or in the APIs. And in Oracle Database at Azure, the way it works is that you have the infrastructure in the VM cluster. You would create that in the Azure portal, whereas in the anything about the database, when you create it and do database lifecycle management, is performed in the OCI console. So what that means is you can install and manage everything here. You've got control about who accesses your VMs, and we're not allowed to authorize that. And you've got obviously complete control of your data, your schema, your encryption keys, and so forth. So this is why it's leading standard for mission critical. And, we see a wide variety of workloads that you can use it for with your Azure applications, whether this is OLTP, data warehousing, and memory analytics, and so forth. And Microsoft and Oracle combined, if you've got combined workloads on premises, they can be effectively consolidated and migrated to Oracle Database at Azure for those customers with an Azure first strategy. Next slide, please, Tammy. Thank you. So I'll just quickly take you through some of the architecture for those of you who've not seen our previous sessions on Oracle Database at Azure. We actually did the last one as a deep dive in the networking. So please do look at that replay if you want more information on this. For now, I'm just going to walk you through the diagram of how it actually works. So on the left-hand side, you see we've got the Azure region with the availability zone. And this is where we've got, the Azure, the X9M, excuse me, right now is the hardware that we've got, and that's delivered into your Azure availability zone in the Azure data center. On the right-hand side, we've got the respective OCI availability domain. So I'll just take a little bit of time just to explain what the OCI child site means and our availability domain connection. So in OCI, each availability domain has one or more data center with the child data center sites that's acting as an extension of the OCI availability domain fabric. So for Oracle Database at Azure, you can see on the left-hand side, we've got something called the OCI child site, and we build that inside the Azure data center, like I said, and connect them to a specific OCI region that's closest in terms of physical proximity and network distance. On this diagram, you'll see within the AZ that we have a delegated subnet, and this is required in the VNet in Azure in order to deploy an Exadata VM cluster. And with this architecture, therefore, the Exadata database service data plane is deployed in Azure. That's how we do it. Now, just to explain a tiny little bit about the networking, when you create an Oracle database at Azure database cluster in the VM cluster, excuse me, in the subnet in your virtual VNet, behind the scenes, what happens is you've got your backend OCI virtual cloud network on the right, and that's created with an equivalent subnet inside that backend VCN. And you'll see that it will have the same IP CIDR range as the subnet in the Azure VNet. That VM cluster then launches in the OCI subnet, and the required virtual network cards, the VNICs, with the OCI subnet in the customer's VNet are assigned and is created as part of that cluster launch. Those private IP addresses are reserved on the subnet in Azure VNet. And then what we do finally to actually create the mapping is we join the two between the private IP in the customer VNet and the VNIC at the back end through this direct Azure OCI connectivity within the Azure data center. So I'll just talk a little bit about the OCI managed network as well. It's very important that when the app in the Azure VNet connects to the database using the assigned IP addresses, we have that Azure Virtual Network Service routing the packets through the OCI managed network to the edge gateway. And that is located in this child site that we've got depicted on the left. And those virtual networking services route those packets. The direct private network is called the OCI managed network, and that's that piece right in the middle. And network traffic for the OCI control plane, as well as OCI vault encryption and backup, go through that OCI managed network. Therefore, the OCI managed network is really playing an important role in delivering low network latency between clients inside the Azure network. And that's how we're keeping this very close proximity, lowest latency possible. Right, so now I'm going to hand over to Sinan. Thank you very much, Sinan, as our guest speaker. You're going to take us through Oracle Maximum Availability Architecture, MAA we call it. So please take it away.
Yes, thank you, Tammy. Thank you, Suzanne. Hello, everyone. Welcome to today's session, talking about maximum availability architecture for Oracle database at Azure. Maximum availability architecture is a reference architecture for high availability and disaster recovery. So to help you how to design your architecture to ensure high availability for your database and for your applications. And also it includes experts' recommendations and customer insights. So we have these customer insights while we are working with customers for decades now, and everything we learn from them, we include this in this reference architectures and these recommendations to increase the availability level. While using, for sure, all Oracle database high availability and data protection solutions like Oracle Data Guard, RMAN, application continuity, etc. these reference architectures are like valid for generic system, for engineered systems, for Oracle Cloud, and for autonomous database. And also they include recommendations while moving to Oracle Cloud when you use zero downtime migration. We have different levels of availability service levels. When we talk about maximum availability architecture, and it goes from bronze to silver to gold, and then to platinum, and which each level, the high availability and the data protection increases, and the service level increases. So we have bronze with single instance databases. So we don't talk about this in the context of database at Azure, because here everything comes by default on Exadata and on Oracle RAC. So we have the silver level by default. And then when we add Active Data Guard or Data Guard to it, then we have the gold, that achieve the gold level. And the Oracle MMA team has just recently validated Oracle database at Azure for the silver and gold level, and put recommendations and findings in place. You'll find this in the documentation. What service level, the availability you can achieve, like zero downtime for planned maintenance, zero downtime for node failures, near zero downtime in case your availability zone goes down, etc. So for the different outages scenarios, or for the different planned downtime scenarios, we have the corresponding downtime or no downtime that you are going to expect if you go with the server level architecture, or if you go with the gold level architecture. So the silver level architecture, as mentioned, is based on Exadata Cloud Service on dedicated infrastructure running in Oracle database at Azure. And it is built by default on Oracle RAC. So every database you create on that VM cluster, it will be running Oracle RAC by default. Then you benefit from the Exadata scalability and availability. You can add storage and compute nodes as needed without any downtime. You can increase or decrease CPU memory and Exadata storage without downtime. Then you are protected against node failures, because Oracle RAC means we have a database with two database instances, right? And then if one database instance goes down, then your database is still available and accessible through a second database node. Also, if we go with software maintenance, if you are patching the VM, the operating system, or if you are patching the grid infrastructure, or even the database, then you can do this in a rolling manner. When you are applying, first of all, database release updates, which are Oracle RAC rolling, and then you take one node down, you patch that node, and then you take it up, and then patch the second node, etc. So at all times, at least one database node is still available to be accessed by your application. Also, we include automatic backups to object storage. As here we have one database. So if you need to restore that database, then you will have your backups available. But before going to that, one more thing here as well is when you create the database, you will find by default the selection in the OCI console is that you will go with the TDE wallet key management on the local host. However, we provide you with a recommended option to use OCI Vault, which is the customer managed TDE and encryption keys. Here again, just to remind you and make sure to understand the workflow. First, you create the Exadata infrastructure and the VM cluster using the Azure portal. And from there, there's a link that takes you to the OCI console, where you can then create your Oracle RAC databases and choose what TDE key management you want to use and what configuration for object storage do you want to use. So for object storage for automatic backups, it is the same experience you already know from Oracle database on Exadata database infrastructure in OCI. And we have done quite a lot of enhancements on backups into object storage. For example, if the backup is configured to be taken from one specific node, and if that node is not available for any reason, then that backup will still succeed because it will be running on another available node. So we will recognize the situation, and then we will run the airman job on another available node. So your backups succeeds, and you reduce the recovery time if something happens to the database. We also have backup on a primary and or the standby database. At the same time, this becomes more interesting if we have a cross-region data guard. So you have backups in both regions, and you don't need to worry about any backup replication. Also, backups into object storage are three ways mirrored. So we have of every block, three copies of that block. If we are talking about OCI regions with the three availability domains, then these three copies are distributed across the three availability domains. Otherwise, the copies will be distributed across the three fault domains. If you go to the OCI console and click on Configure Automatic Backups, you will see you can choose the backup destination as object storage. You can choose the retention period. We provide you options to choose the weekday for the full backup. It doesn't need to be Sunday if you have different workloads that run extensively on Sunday or on weekend. Usually, then you can choose another weekday where the full backup will be executed. You can define the backup time. The archive log backups are done automatically every 30 minutes, and the backup retention, you see here, you can choose between 7, 15, 30, or 60 days. We also have restore capabilities using the cloud automation, where you can restore the entire container database to the last backup, to a specific point in time, or to the last SCN number. If you want to restore specific PDBs, you can do this either manually or even using the dbus CLI, which is a command line that is available when you log into the operating system to your VM cluster. And object storage cost is based on, for sure, the size of your database, and for sure for the retention period, because as higher the retention period is, the longer we will need to keep your backups available on object storage. Also, just to remind you at this point, if you have any questions, please put them in the Q&A. Okay. Then to take it to the next level, which is now the MMA Gold level, we build on top of the silver level, which is based on Exadata and Oracle RAC database. We put another Exadata infrastructure with a VM cluster in a second availability zone. And that protects us from complete availability zone failures or from database failures, or if we are doing rolling upgrades. So doing upgrades from one major release version to another major release version, like 11.204 or 12.01 to 19C. For that to be done without or with minimal downtime, we need data guard. So we upgrade the standby first and then the primary for rolling patching, and patching means you are in the same release update in the same release, major release version, 19C, and you go from 1918 to 1919 or to 1920. So you do this just on the primary database, for example, in a rolling manner, node by node. Okay. Data guard can be set up automatically using the OCI Cloud Console or the Cloud APIs or OCI CLI. CLI. Then with Data Guard, we have, in addition to site failure protection, with Active Data Guard gives you even more comprehensive data corruption prevention. For example, we have with Active Data Guard, block corruption detection and automatic repair. Like if database block get corrupted either on the primary or on the standby, this will be detected automatically, and that block will be replaced by the block from the primary or from the standby, depending on where that block was detected, without any human intervention. So this is really a great feature that comes on top if you are using Active Data Guard, which is an additional enterprise option. And as mentioned, you can do also rolling upgrades with minimal downtime. And with Active Data Guard, you can automate this process of rolling upgrades while using the DBMS rolling package. And with Active Data Guard, you have the standby database open for read workloads for reporting, and also now with 19C for not only read only, but read mostly, we call it now, because you can even do DML on the standby database, and then we will redirect that. So the feature is called DML redirect. If you insert or update any data on the standby database, we will then automatically redirect those on the primary, will be applied there, and then via radio transport, this will be then applied on the standby database, and then your application will appear to your application as if it were applied on the standby database directly, and your application can do like a bunch of reporting, and at the end of the reporting, write a summary about that reporting into the standby database. Okay. Just to highlight once again here, if you want different backups again from primary and the standby, you can have them here as well. However, in the same region, you can use the same backup to restore the primary or to restore the standby if you are doing it manually, but using the OCI console, probably it is then more recommended to have automatic backups configured on both primary and on the standby. Then you don't need to switch and to think about where to enable automatic backup if rules switches, if it is an intentional switch over, or if it is a failover due a failure. If you configure automatic backup on both, then you are fine. Whatever the primary, whatever the standby database, you always have backup from both databases. Key management, it needs to be the same key that both the primary and the standby databases have access to it. So OCI Vault is a regional service, so the TDE keys will be stored in OCI Vault, and both primary and the standby access the same TDE keys. If you go with TDE wallet on the local host, then this TDE wallet will be copied on the standby host as well. Then you have the same keys on both hosts. Those the standby database have access to the same database keys. This is the OCI console experience. When you enable Data Guard, you just go to the Oracle database overview page, and then on the left side, you have the Data Guard Association section. When you click on it, you have the button here, Enable Data Guard. When you click on it, you will choose the region, choose the availability domain, then choose the Exadata infrastructure where your standby database will reside, and then the Exadata VM cluster where your standby database will reside. And then you can choose between active data guard or just the standard data guard. Then in the next section, you can choose the protection mode if you want to go with maximum availability or maximum performance. If you want to do synchronous or asynchronous radio data transport. We have a lot of materials going deeper into the different modes, the different protection modes, the different transport types regarding data guard. So to learn more into deep dive into data guard, can encourage you just to go to the Oracle documentation and learn more about these specifics for enabling and doing data guard. So in a summary, asynchronous replication means when you put your transaction to the database, as soon as the radio is written to the online radio logs to the radio buffer, sorry, then yeah, with the commit it will be flashed to the online radio logs. Then the commit is going back to your application. So your application is not waiting and gets higher performance. If you do with synchronous replication, then we will send the radio to the standby database first. And once it is received by the standby database, then the standby database acknowledges the primary database, and then the primary acknowledges the application that this transaction was committed. So you have a bit higher latency, probably depending on where your standby database is. But for that, you have zero data loss, because whatever happens on the primary at any point in time, you have zero data loss with synchronous replication, because that transaction was already pushed or already transferred. The radio data of that transaction was already transferred to the standby database because you got the commit acknowledgement. Then you select the database home. You have the option to provide a custom database unique name. You enter the database password, and then you enable data guard, and that's it. All the configuration in the background, this will all happen automatically. All the parameters needed will be configured as per our Oracle MMA recommendations. So you don't need to worry about anything, and just click the button and the data guard configuration will be set up for you, also including the data guard broker configuration. For Oracle database at Azure, as you have seen, Susan introduced the high-level architecture to you, where you remember you had the Azure network on the left side and the OCI network on the right side. You can choose where your data guard traffic is going through. For both options, you can use OCI Cloud Automation to enable data guard, but then depends in the background where you enable the VNet or the VCM peering, and you enable the routing, then your network traffic will go that route that you have configured. We recommend using the OCI network for the network traffic as per our MMA validation. We have encountered higher throughput and lower latency when you go through the OCI network. And for sure, if you go for the OCI network, then Oracle is in control and ensures the reliability of the network. If you go through Azure, then Microsoft will be in control, or is in control of the network, and ensures the reliability of that network. So for example, we got here 14 gigabit per second throughput for a single process in OCI versus 3 gigabit per second for the Azure network. Lower latency here was like 20% lower, or in other words, in Azure was it 20% higher latency, and across the availability zones, it is around or even less than one millisecond. Also, another benefit for you as a customer, if you go through the OCI VCN, is that across availability zones within the same region, there is no charge for ingress-egress traffic, where there is some charge on the Azure network side. The OCI automation provide one standby database via cloud tooling, via cloud automation for the moment. So if you need additional standby databases, then you will need to add them manually. And if we want to have a fast start failover, so if something happened to the primary database and you don't want to interact manually with the failover operation, but just to get it detected automatically by the observer and do the automatic failover, so you reduce the recovery time objective. Then you can install the observer on an additional VM and enable fast start failover for the data guard configuration. Okay, so here again, some further reading for you for the Oracle Maximum Availability Architecture, the validations we have done for Oracle Database at Azure, and the recommendations, and the reference architecture, and also we have MMA best practices for Oracle Cloud, Hybrid Cloud, and Multicloud. We will share these slides with you, right, Suzanne and Tammy, if I'm not mistaken. And then you can just click on the links and go for it and have more information on these topics.
That's right.
We will. Oh, sorry. Yeah, we will. Upload.
Answering questions, Tammy.
Yeah. Great minds think alike. We will be sharing the slides with the replay on the Ask Tom link that you were at to join this session as well. So we'll get those uploaded within the next 24 hours. They'll be there available for you.
Thank you. Yeah, and then I take the opportunity and hand over back to you to summarize, Tammy and Susan. Thank you for having me here today. Thank you, everyone, for joining. If you have any questions, just put them in the Q&A or reach out to us also after the session.
Thank you, Sinan. Really appreciate that. And thank you, Suzanne, for all this as well. As you can see, that Oracle and Microsoft, we deliver the Exadata database service on our Exadata infrastructure co-located in the Microsoft Azure data center. And as you can see, the benefit of being to lower the latency, make it very fast, to provision your databases and your applications and get started on your development of applications, as well as getting into production as well with your current applications as well. Running on the Exadata database service, hopefully you can see the benefits with the Exadata platform. As Suzanne mentioned, it's been around for, I think, over 15 years, and we continue to enhance the capabilities, and I think we call them smart storage and unique algorithms to work with the database and the hardware together to give you the best performance, availability, automation, available to run your Oracle database on as well. And finally, with this Oracle database and Azure solution, as you can see, this partnership with Microsoft and Oracle, we want to make it much easier for you to create your solutions or run your solutions in the cloud, be able to modernize, innovate with the latest capabilities that are available. We're really excited to see all the new functionality that's coming out this year. I hope you stay tuned and you'll get excited to hear from Oracle later in May to see all the great innovation coming out there as well. And also, because of this partnership, we're trying to make it easier so you can see being able to use your Azure commitments with your Mac burn down, and also being able to leverage your Oracle licenses as well. So I really am excited about this partnership and how we work together. But mainly it's because for customers like you, working with customers like you, to bring good solutions to your business. And as we all know, that's really important today. Okay, so there's been some great, thank you for asking all these great questions on Q&A today. I know it kept me quite busy for the last few minutes, so we really do appreciate all the interaction and all of your questions as well. So Bala asked one, when is the Exadata shared and autonomous expected at Azure? Stay tuned, you'll hear more about that later in May. Yes, I am. We will share the deck. I will PDF it and upload it with the recording within the next 24 hours, or as soon as I can today, hopefully. So by tomorrow, when you log back in to Ask Tom, you should be able to find the recording as well as the slides. We do have an external Slack. We would love for you to join us on that. We make announcements and there's good conversations going on with other customers as well. So we have a couple of minutes. If there's any other last minute questions that you may have, please post them in Q&A. If there are any specific topics that you would like to hear about multi-cloud solutions, post those in Q&A as well. We'd love to hear from you about that. We love to bring you this information and share the information with you as well on how we can help you. So with that, in the last few minutes, yes, Suzanne, I was just going to ask, do you have any last minute comments?
Yeah, I just want to just go through can you go to the architecture diagram again? It's just, we had so many questions on egress and ingress charges as well, mixed in with like the different scenarios.
Yes.
I just would like to reiterate and maybe ask Sinan if you'd like the opportunity to make any comments
There we go.
on this, because when we're looking at this architecture diagram here, this is the encapsulation of the Oracle database at Azure Service in its entirety. And as one of the questions asked, where is the database? So, you know, we explained that the database itself, like Tammy answered, is in the Azure data center. So that means the hardware, the platform itself is in the Azure data center, in the AZ depicted on the left. And in this OCI child site, as Tammy said, it's co-located in that Azure data center to bring you all that, you know, the goodness of the Oracle database, Exadata database service. Obviously, there's a dependency on the OCI region, which is the most closest in, like I said before, in proximity and network distance that we make available to you. And we need that because we go back and we talk to the control plane. And there was a question on key rotation. So it's important that you would then administer that, like Tammy said, through the key rotation from OCI Vault in OCI. And that, you know, we need this OCI managed network then to traverse the traffic between the left side and the right side. Now, between those 2 points, there is no egress charges here. You're still in the region, and we cover there's no additional costs in that respect. However, as Sinan can allude to, when you start doing cross-regional architectures, nothing changes there. Obviously, you know, we've got still egress charges applying when we're actually doing architectures across region and so forth. And if you've got traffic going back and forth outside on premises back into OCI for any reason, then you've got to obviously cover your egress charges there. And we in OCI have very, very attractive pricing because we offer the first 10 terabytes of egress for free per month in that region. So Sinan, if you would like to explain anything else on MAA egress charges, if anything else comes to
Thank you.
mind.
As you explained, if you like, here we have the second availability zone, or let me go to the slide where we have the data guard configuration.
Multi-AZ, you mean?
So the multi-AZ, if you go through the Azure VNet, so if you go from this is your primary VNet, right? And this is your secondary VNet in another availability zone. And this is the primary database here, and you have the standby database here. So the data guard traffic, when you configure it to go from the primary database to the standby database over the Azure network, then there are ingress and egress costs associated with cross VNet traffic. So these VNets needs to be peered, right? You will go to and peer these VNets so they are reachable from each other. And then when the traffic flow from one side to another, there is egress cost when traffic leaves this VNet, and then there is ingress cost when traffic arrives to this VNet. However, if you combine this with the previous architecture Susan just mentioned, you have on the other side here the corresponding OCI VCN on the primary and OCI VCN on the standby. And then when you peer, instead of peering these VNets, when you peer the VCNs, which either with each other with the local peering gateway and configure data guard traffic through routing tables to go through the OCI VCN and then to the other OCI VCN to the standby database, then no egress charges will be there, because in OCI we don't have any ingress costs for in region or across availability domain or within the same availability domain traffic when traffic traverses from one VCN to another, whether in the same availability domain or across availability domains. And even across regions, we have the first 10 terabyte per month are for free, and then starting with, after 10 terabyte per month, then you will be start to be charged for that.
Yeah, so the diagram I showed previously was just within one AZ. So I was speaking about traversing from the AZ VNet across to RAD where you don't incur egress. But as you rightly point out, Sinan, when you've got multiple VNets, you know, in any case, in any scenario, right? You've got VNet peering charges that apply on the Microsoft Azure side. We're not going to speak for Azure pricing, but they do state on their website that it's reasonable pricing or some other kind of word that they use. But basically, they're alluding that it's not their standard. It's not as high as their ingress and egress charges that they pay for virtual networking. The VNet peering is charged at both ends. And you can see the prices printed if you do a search for VNet peering. But excellent, thank you, Sinan, for pointing that out. Because it, like we said, it depends on the configuration and the kind of scenarios that you've architected as to what you'll be charged. But
Yes,
certainly,
so
what we're trying to do,
highlight this one more time, through our testing, we found out that going that route gives you even higher throughput and lower latency.
Lower latency, yeah. But we're certainly doing our very level best to make it easier and offer the non-egress charges between obviously the Azure side and the OCI side when it's in one AZ and one AD together, like we said on the previous diagram. All right, thank you.
Thank you. That was good. Any other last minute questions? To everyone in our local peering gateway. Oh, that's a good question. Their question was, do we have a recommended doc on local peering gateway setup for data guard? I believe that is on the Azure, in the Azure documentation. And I don't know if I have that. Local, I don't have that readily available. Sinan, do you happen to have, or Suzanne, the Microsoft documentation?
Yeah, I'll double check.
Just double checking on that while we're looking. If anybody has any other last minute questions while we're looking for that link for you.
For the local peering on the OCI side, you'll just follow the standard documentation on OCI, right? This is just the same procedure you will follow when you peer to VCNs, and this is also included in the Exadata documentation. We'll just need to find the link for you.
Is local peering on OCI or local peering on Azure? Because there was two sides to it, I thought. Maybe not.
Yeah, so yeah, you could do the local peering on the OCI side, or you could do it on the Azure side.
Okay, so here is the main link. I'll just put this in the chat in a second. That is the main link for Azure. And then let me go back to our documentation. And I'll point you to the, I think it is in the chapter on setting up Data Guard. I'm almost there. Bear with me for a second. There we go. So I'm putting two links in the answers. There you go. So I just posted one link to the documentation over in Azure, and I also posted the link in our documentation as well. Venkat, you have a question?
Sorry, Tammy, just before you go on, I also, in terms of local peering gateway and whether how you set that up on the network side without bringing Data Guard into occasion, there's a really fantastic hub and spoke document white paper that we've created talking about deploying the Oracle Cloud and Microsoft Azure Interconnect on either side using hub and spoke and local peering gateway as well. So I can put that in the chat too. Shall I put it in chat or in Q&A? Tammy, shall I put it in the chat?
Yeah, go ahead.
Yeah, I'll put link in the chat. Can people see that then? Or do I have to put it in Q&A?
No, you can put it in chat for everybody.
Okay, that's fine. I just thought I heard you say you hadn't done that. 1 second. This is...
No, you got to send it to everybody.
Yeah, I clicked on the mouse too early. Sorry, that's why I still wait a second. Okay. So I'll just put this in this is the oh, sorry, I've done it again. This is it. And then I'll just put the link in as well. Because it's a good networking white paper.
Okay, awesome. That went to everybody. Everybody should check their chat for that link that Suzanne just put in then. Okay, I think with that, we'll wrap up today's session or this month's session on multi-cloud. Thank you again for joining us today. We really appreciate that. We hope you found this helpful. And join us next month on our next multi-cloud happening session. And we're excited for you to join us. And like I said, if you have any topics that you would like to hear specifically around multi-cloud, just let us know and we would love to address those for you. All right. Thank you, Suzanne. Thank you, Sinan. Really appreciate everything that you shared with us today. Thanks. All right.
Bye.
Bye.